12.5 is a section of the book you've probably been waiting for. It's about doing logarithms on your calculator. But please don't misunderstand what we're teaching you here. We're not trying to replace what we've already learned in the previous couple of sections. In fact, I want you to sort of think about two similar square root problems and how you would be expected to work these out. The first one, if I had that as part of a question or a question all by itself, if I saw a student reach for a calculator to work out the square root of 49, that's kind of a problem. That's not a good sign. People should be able to work out the square root of 49 by hand just by knowing what square root means. If they can't do that, something isn't working right. On the other hand, a very similar problem, square root of 50, it's really close to 49, that legitimately does require a calculator. I would expect you to grab a calculator, press some buttons, square root of 50, and get 7.07106, etc. for however many decimals are important for that problem. The same thing is going to be true of logarithms. Some logarithms, like we've already been doing for the past couple of sections, you would be asked to do those by hand and expected, and it would be reasonable to do them by hand. But some logarithms would not be expected to be done by hand. They would legitimately require a calculator, and that's what we're learning about today. Do not just grab a calculator for every single logarithm, but when it's necessary, we're going to learn how to do it. So, first of all, take a look at your calculator, look at the front of your calculator, all the different buttons on there, and I bet you will find at least one button specifically for logarithms. You might have already seen it before. There should be on your calculator a button that says log. It might be in all caps, it might be lowercase, it might even require to use some sort of like second or shift kind of a button because it's above another button. But that button, that's not really what you might have thought it is. It doesn't actually mean just any logarithm at all. That means specifically log base 10. So if I were to ask you that base, like log base 10 of 19. There we go. Could you do that by hand? Certainly not. There's not going to be a nice power to put on 10. 10 to the what is not going to give you 19. So that is legitimately a calculator question. This button lets you do that. Log 19 on your calculator. You would get 1.2787, etc., 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 for however many decimals would be important. This type of logarithm, the name for it is the common logarithm. But it's not that it's common like you've seen it a lot. I mean, think back to the homework we've been doing over the past couple of sections of the book. We have not seen log base 10 all that often. I mean, we've seen log base 2, log base 5, log base all sorts of different things, and maybe log base 10 once in a while. But it's not exactly that it's frequent. So it doesn't mean common like frequent. What it means is common like in the sense of being universal. Our number system that we use is base 10. It's all based around tens and hundreds and thousands, powers of 10. So logarithms base 10 are kind of universal. So it's common in that sense. The other button that you may have on your calculator for doing logarithms doesn't necessarily look like logarithm at all. It's ln. And what that one stands for is a different specific logarithm. It means specifically log base e, and that's called the natural logarithm. Now there are two questions that this naturally leads to. The first question that it naturally leads to is, okay, what's e? You haven't seen e before unless you've studied logarithms before. It's a letter. Is it a variable? No, it's not a variable. It's a symbol that stands for a number, sort of like pi, sort of like I. It's a complicated, irrational number. It's a 2.718, etc. It's one of those infinitely long decimals that never settles into a repeating cycle. It's a true irrational number. And then the second question that naturally leads to is, why is this called the natural logarithm? There's nothing natural about 2.718, etc. Why would somebody naturally think of that? Well, they wouldn't. It doesn't mean natural in the sense of being instinctive or psychologically reasonable. It's natural because it sort of comes up automatically when you study certain things mathematically. Things like compound interest, or population growth, or radioactive decay. In those situations, if you try to come up with formulas to model what's happening, you kind of automatically get stuck using this weird number for the base of a lot of things. So it's natural in the sense that it's part of nature. It's not natural in the sense that there's anything instinctive or obvious about it. The other thing is, the reason why we use the letters Ln to represent that is because the people who were first studying logarithms, they were not people who were primarily speakers of English. It originally came from French. It came from log natural. Now, if you say it in another language than English, it's not necessarily going to be in the same order. It wouldn't be NL, it's LN. So if you're thinking everybody in the world speaks English, surprise, there's lots of other languages in the world, and math is often invented by people who speak some of those other languages. And that's one of the nice things about math. We really don't care where a person comes from as long as they can do some good math. What language they speak, do they speak math? That's what we care about. Now, both of these logarithms are extremely limited. There's just log base 10 and log base e. What about all the other logarithms you care about? That's a very reasonable question to want an answer to. What about logarithms with other bases, other than base 10 or base e, like just about every other logarithm we've ever seen? Well, the good news is there's a thing called the change of base formula that will allow you to do exactly what it says it's going to let you do. It will allow you to change the base that you're working with. Here's what I'm talking about. Let's say you're trying to work out a log base 5. You look at your calculator. Your calculator does not have a button for log base 5, but it does have a button for log base, let's go with log base 10, the common logarithm. So you're probably thinking to yourself, gosh, I wish I could just go in here and get rid of that 5 and write a 10 instead, and now I can do it on my calculator. Well, of course, that's cheating. You can't really just change the base like that. But this change of base formula does show you a legitimate, reasonable, accurate way to change the base. I would like the base to go from being one number to being a new different number. Currently it's base 5. I'd like it to be base 10. So, looks like what I do is I write the logarithm with the new base up there. So see where that a was? Now that's the new base. The 19, that's the x here. So that doesn't change. It's still logarithm of 19. And be careful about the denominator here, because this is the key to the whole thing. This is the thing that sort of corrects for how you've changed the base. Base 10 and base 5 are not the same. This correction factor is the logarithm of the old base using the new base. So the new base is base 10. We're going to have to do log base 10 of the old base, which was 5. And this you can do on your calculator. You have a button for log base 10 of 19. You can press 19, take the logarithm of that. You can do the same thing for the denominator. You have a button for logarithm of 5. You work that one out and you divide the results. In fact, you might want to pause the video and see if you can work this out on your calculator, but let me warn you before you go too far down that path. Some calculators work differently than other calculators, and what I mean is, when you do a logarithm, some of them require you to press the 19 first and then press the logarithm button afterwards. Other calculators have you press the logarithm button first and then type in the 19 after that. So you may have to experiment on your calculator to figure out which way your calculator does the job. Go ahead and pause the video, see if you can work it out, and then I'll tell you what the answer comes out to be. All right, so if you work that all out and divided correctly, your answer comes out 1.8294828, etc., etc., etc. And your calculator might have more decimals than mine, but it'll be pretty much like this for the first 6, 7, or 8 decimals. You should also have some sort of rough instinct about how big the answer needs to be, because if you get one part of this backwards or press a button wrong or make some kind of a mistake, you are still expected to be able to check your answer at least with some common sense. So here's what you should be thinking about. Remember what logarithm actually used to mean when we were first studying it. It means 5 to some kind of exponent has to come out giving us an answer of 19. So the answer definitely has to be bigger than 1, because 5 to the 1 is nowhere near 19. It's way too small. On the other hand, 2 is too large. 5 to the 2 would be 25, and that's bigger than 19. So the answer should be between 1 and 2. It should be a little closer to 2, because 19 is closer to 25 than it is down to 5. And then when we look at this answer passes the common sense test. It's in the right rough estimate of what we would expect. So don't just fall asleep and let the calculator do all your work for you. Stay awake and keep thinking about what things mean, so that when you get an answer, if the answer is wrong, you can find out what you did wrong and fix it, rather than just being wrong and not even knowing it. That would be bad.